All right. Hi, everyone. How's everyone doing? All right, let's try that one more time. How's everyone doing? Awesome. All right, so welcome to Best Practices with Azure and Kubernetes. If you were here because you wanted to see Abel Wang play guitar, you will have to go to Twitter for that. We are going to talk about Kubernetes today, obviously. I'm going to first introduce myself. My name is Jessica Dean. A little bit about me. My background is primarily Linux, open source, containers, and IT operations. I am not traditionally a developer. However, I do develop and focus on infrastructure. I also work on a team focusing on DevOps. I've been asked several times when I present on this same exact content why I don't put DevOps up there under the first bullet point. The reason why is because DevOps is a culture and a mindset. And everything that I do, DevOps is a part of. And we're going to talk about that because DevOps really sets the stage for containers and Kubernetes. I'm also super big into CrossFit and fitness. I try to drop into a CrossFit gym, or at the very least a hotel gym, in every city and every country on every continent I go to. So if you ever see me in the hotel doing something weird like handstand push-ups, or you've seen it on Twitter, don't freak out, it's totally normal. I am also a huge Disney and Star Wars fan, and I don't say that lightly. I have Han Solo's blaster tattooed on me. I have Luke Skywalker's hilt. I have a Disney, Star Wars, Harry Potter crossover, complete with Doctor Who, Zelda, Lord of the Rings. I like having fun, and I like being super, super geeky. And then finally, I'm a member of what we call the League of Extraordinary Cloud DevOps Advocates, or we just call ourselves the League. You might have heard about it or seen it trending on Twitter. We'll talk a little bit about it after Abel introduces himself.
Thanks.
Mic issues.
So it's great to see you guys. My name is Abel Wang. I am a senior cloud developer advocate specializing in DevOps. Now, that's a big, long, fancy title, right? What is it that I do? What is it that I actually know? I write code. That's what I do. I write code. I eat, drink, live writing code. It defines who I am, and it makes me ridiculously happy. So to give you some perspective, I'm that weird dude at Microsoft, right? After a really long, stressful day at work, writing code, the way I wind down is I go back home, I play with my dog, I talk to my wife. She picks a TV show to watch, because she always picks the TV shows. And I pull my laptop out, and I start writing more code to wind down, because that's what I love to do, right? So I'm that guy. So some things that I've done, I've been a process consultant. I've been an ALM ranger. I write code with the VSTS team. Area of specialty is definitely around DevOps, general app dev, Visual Studio, and of course, Azure. Now, some fun stuff. Back in the day, I used to be a real rock star. Or in my mind, I thought I was a real rock star. But apparently, I wasn't very good, because here I am in Seattle talking about Kubernetes and not playing my guitar. So that career kind of petered out. I'm also a runner. I freaking love to run. So my dream is one of these days I want to run on the Great Wall Marathon. I want to run a marathon on the Great Wall. That would be amazingly awesome. But I've heard that it's like the third hardest marathon ever, so I'm training pretty hard because I don't want to be that guy in the red throwing up in the middle of the wall. But that probably will be me. So that's who I am, and that's what I do. Along with Jess, I am part of Donovan Brown's team of DevOps advocates, and Jessica will talk about that more.
Thank you, Abel. Now my issues. Apologize for that. Give me a second. Thank you, Abel. So yes, we both are a member of what we call the League of Extraordinary Cloud DevOps Advocates. You can hashtag us or tweet us or follow us at LOECDA. When you do use that hashtag, we actually get a notification in our Teams room, and we'll come answer whatever question, engage in whatever conversation. If you want to talk about Star Wars or code or Kubernetes or whatever you want to talk about, we're very responsive. But what I love most about this picture is we really embody and embrace what DevOps is, and I keep mentioning it. We're led by Donovan Brown. You probably saw him talking about DevOps in the keynote this morning. And then we have Damian Brady, we have Abel, we have Stephen Murkowski, and then we have myself. But even the way this picture is structured, We have Abel, Damien, and Donovan on the left, and their backgrounds are primarily developer backgrounds. Stephen and myself, which, by the way, we're doing another session on containers tomorrow at 3 p.m. It's a little bit more high level, a little bit more intro. If you feel this session goes a little too deep, I encourage you to check out Stephen's in my session. But Stephen and I both have operations backgrounds. So we're really kind of coming together, the 5 of us, and we're able to truly embody what this DevOps culture is without any wall. But as awesome as the league is, we are only a small part of the cloud developer advocacy team at Microsoft. It's a relatively new team. There's about 60 of us, and we are located around the world. So whether you have a question about .NET, Linux, containers, Kubernetes, IoT, machine learning, AI, you name it, we have an expert on our team. And the best part about it is we are so passionate about what we do. It's not just Microsoft focused, it's code focused, it's software focused, it's value delivery focused. And we're going to talk about why that's important. So let's dive right into the content, because you guys want to learn about Kubernetes and best practices and Azure. But first, we kind of have to talk about why all this matters. We have to talk about the current state of technology. This study, all the statistics on it, was performed by Gartner a few years ago. And they said that we are going digital. Some would argue that we've already gone digital. They estimated that by 2020, 1 million devices per hour would be coming online. I'm just going to repeat that. 1 million devices coming online by 2020. This is 2018. That's less than 2 years away. That's rapid growth. They also estimated by the same year that the average age of an S&P 500 corporation would be 12 years of age. Compare that to 1960, where the average age was 60 years old. Companies are getting younger. We have more devices coming online at such a rapid pace. And then finally, they estimated that by 2025, 60% of all computing would be done in the public cloud. And I actually feel that statistic is a little bit low, because we already are seeing such a shift and such a movement to the cloud, right? Everyone is talking about the cloud, whether it's an on-prem or hybrid scenario, the cloud is being mentioned. Your grandmother is talking about the cloud. Fun story, I was in Paris about 2 months ago speaking at Tech Summit Paris. I was having breakfast at this little cafe, and the table next to me, I was overhearing and eavesdropping because I'm nosy, and I noticed that the mother and daughter, who were there for spring break, spoke English. So I kind of leaned over, I asked where they were from, I asked what they were doing here. They asked me the same. I told them I worked for Microsoft. They immediately stopped and said, "Do you know where the cloud is?" And I laughed and I said, "Actually, I do know where the cloud is. That's what I talk about. I talk about Azure. It's Microsoft's cloud." And they responded, they said, "No, I'm going to tell everyone, I know where the cloud is. I met the cloud, and the cloud's name is Jessica." It's a funny story, but everyone's talking about the cloud. People don't know what it means, but they want to talk about it. Why? First, let's talk again still about what we're seeing in our state, our technology, our IT world. Here's what we hear from developers. And for the developers in the room, just by a show of hands, I know we're at Build, I know this is a developer conference, but how many of you would feel comfortable identifying yourself as a developer? Most of you. Are there any people that would focus more on IT or operations in the room? A handful, so we still do have some. So for the developers in the room, tell me if this sounds familiar. I need to create an application at a competitive rate without worrying about you as IT. Or my applications run smoothly on my machine, but the second it hits your server, IT person, it breaks. It's your problem. Sounds familiar, right? Or my productivity and application innovation becomes suspended when I have to wait on you, IT. IT becomes the bottleneck for developers. Sound familiar? Don't worry, I'm getting to you, IT. I'm not leaving you out. You get to have your time, too. So for IT, your perspective is, well, I need to manage security and maintain compliance with little disruption on my servers. I can't just give you access. You can't RDP over to it and do what you want. On top of that, I'm not a developer. So when you hand me your files and tell me to deploy it and it doesn't work, I can't debug it or troubleshoot it on my own. I need to work with you. We have to work together. And then the last one is I'm unable to focus on both server protection and application compliance. I can't work on making sure my server is secure and your code is safe. So how do we address this? Regardless of where you work or where you fall in the industry, if you work with software, if you write it, if you deliver it, these are your pain points. You have to worry about security threats, you have to worry about efficiency, and you have to support this rapid innovation that we just talked about. That's why cloud is important, because cloud is the new way to think about data center. Your traditional model was that you had dedicated infrastructure for each application. The hardware you were using was purpose-built, and your infrastructure and operations teams were distinct and separated. I often use an analogy of it's like a sixth grade dance. You have people on one side of the room, people on the other side of the room. No one wants to come together and hang out and have some fun. And then previously also, the processes and configurations you used were customized and tailored to that project. But it's not scalable, it's not effective, and it's not going to be able to grow with this rapid momentum. So that's where cloud comes in. Cloud really encompasses loosely coupled apps and microservices. You now have industry standard hardware, and your service delivery teams are DevOps service-focused delivery teams. Your processes and configurations are also standardized. So it makes it for a more scalable, robust solution. That's why DevOps is important. And it is a three-stage conversation. It starts with people. We've identified the people, right? We've identified dev and ops. We've talked about process and standardized process. And then it also encompasses products. And we're very specific when we use these three words, and not just because I was a grammar nerd in college and I like alliteration, but because DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. And my boss actually wrote this quote. But what not a lot of people know, unless they've heard somebody on our team tell the story about it, is Donovan took 30 days to write this quote, because he wanted to make sure that every single word in that statement was something he could stand behind. You might see DevOps described with the word tools rather than products. Here's where we're passionate about the products that you use, the solutions that you use. If you think about building a house, right? And you have tools. You can have a miter saw, you can have a hammer, you can have a screwdriver. You have all these tools. But without the right products, without the right plan, and without the right people, you cannot deliver a valuable solution. You can't build a house. So that's why this is important. So now we're going to dive right into containers and Kubernetes. And I had to go through those three slides for DevOps so you can understand why Kubernetes is so important and what the foundation is for it in Azure. Before we get started, we're going to watch a funny video. Before I press play here, we recorded this video. This is Eric St. Martin right here next to me. We recorded this video at KubeCon in Austin last December. We went through about 7 takes. And this is meant to be a funny, high-level, explains basic container orchestration. You've probably seen some GIFs going around. I'm swatting containers. But when we went through about 7 or 8 takes, there was a woman who kind of stood off to the side at about take 5. She'd been here all week. And she came over and said, you know, I'm not a tech person. I don't really understand what this I can't even say the word stuff is. But I think I finally understand. It's when something fails, it's still available. It hasn't fully failed. I sent it to my aunt. My aunt's also not technical. When she sends me a text, she refers it to as sending a bubble. So I sent it to her, and she had the same response. I get it. It's when something fails, it's still up. So let's just watch it. It's kind of a nice icebreaker. Hi, my name is Jessica Dean, and I'm a cloud developer advocate at Microsoft here at KubeCon.
And I am Eric St. Martin. I am also a cloud developer advocate at Microsoft, but I am not at KubeCon.
Then how are you right next to me?
You're not at KubeCon either.
What?
We've got green screen and an amazing producer.
This is some really good virtualization. So what are we doing today?
We are going to do a live demonstration of container orchestration with something like Kubernetes.
I'm really excited. Let's get started.
Over here, we have our image repository filled with containers that we would like to deploy. Jessica is going to be our scheduler.
Apparently.
So here's our first container, and go. Bad Docker file. Okay, we fixed the Docker file, and we're going to deploy this one.
Yay!
Sweet.
And we can have multiple schedulers, especially for the sake of time.
There we go. Containers, lots of containers.
So let's make sure that we also get our bin packing in order here.
We don't want any leftover memory.
Nope. Gotta be efficient. Always efficient. Look at all these apps we're deploying. This is gonna be the best node ever. I'm so excited for this node. Look at this. so pretty. I can't wait to see this node done. It's gonna be my favorite node ever.
Best one. Hey, Zach.
What's up, man? What are you guys doing?
We're talking about container orchestration.
Yeah, we just deployed a node on the server. We just deployed a bunch of apps.
I mean, really neat. Do you mind if I
Well, actually, now we have node failure. What are we gonna do?
I don't know.
We actually have a Kubernetes cluster.
That's right.
So, want to see what happens when?
Yeah, so let's go over to our other node. Look at that, thanks to Kubernetes, we've taken all of our failed containers and now we migrated them over to this awesome second node. This is fantastic.
It's magic.
I really hope that this helps explain how orchestration works. Thanks for watching social media. You can laugh. I do not mind being laughed at. In fact, that was the intention of the video. So I know that it's silly, but it's supposed to break the ice and kind of set the stage. So why containers? Why DevOps? Remember what we talked about earlier, where we talked about our pain points as developers or operations. Why containers? Containers enables this write once, run anywhere concept for developers. It solves the pain points and the issues of, it works on my system, why doesn't it work on yours? And along those same lines for operations, the biggest thing is portability, portability, and portability. That means that we can have standardized development across all our environments. Our dev, our QA, our staging, canary, prod. All the environments can be repeated the same way because our runtime environments are encapsulated. And we'll talk about how that works. So we're going to dive right into container orchestration. Here are elements of orchestration. Kubernetes is not the only orchestrator. So elements of orchestration are that you have scheduling. You have affinity and anti-affinity, health monitoring, failover, coordinated app upgrades, service discovery, networking, scaling. Orchestration allows both developers and operations to be successful. And Kubernetes is the de facto orchestrator. It's portable, it's extensible, it's self-healing. What does that mean? Portable means that it can run anywhere. You can do public, you can run it privately, you can have hybrid scenarios, you can even have multi-cloud scenarios. It's extensible, it's modular, it's pluggable. And self-healing means that you can have auto placement, auto restart, auto scaling, and even auto replication. It empowers you to do more. You can deploy your applications quickly and predictably. You can scale your applications on the fly. You can roll out your new features seamlessly because you have rolling upgrades. You can also limit your hardware usage as defined in your deployment files to required resources only. So you can limit your resources to CPU and memory, and you can set all these settings manually and per deployment. It solves issues that, again, were the pain points we talked about for both developers and operations. Diving deeper into just Kubernetes container orchestration, we're going to talk about Azure Kubernetes Service. What is it? Flat out, it is your Kubernetes cluster, and it is managed by us. Why AKS? First off, it is easy to use. It is the fastest path to run a full-blown Kubernetes cluster on Azure. You can get up and running with 3 simple commands. And I would argue it's technically 2 if you already have kubectl or kubectl, however you wish to pronounce it, installed locally on your system. It's easy to manage. You can have automated upgrades and patching. You can easily scale the cluster up and down. So by default, the default command I'll show you in the next slide will deploy out 3 workers or 3 nodes. If you want to move up to 10 or 50 or 100, you can do that with 1 command. It also gives you a self-healing control plane. And finally, perhaps the most impressive, it is 100% upstream Kubernetes. What does that mean? It means there's no forks, there's no branches. This isn't a Microsoft-only version. This is full upstream Kubernetes. And these are the commands. This is all it takes to get started with AKS in Azure. And if you want to pull your phones out and take a picture, I encourage you to. The very first command we'll walk through, AZ AKS create. This is using Azure command line. So as long as you have Azure command line installed from any system, you can start deploying out an AKS cluster. You specify a resource group, you specify the name of your cluster, and you use the flag to generate SSH keys. You don't even have to provide an SSH certificate. It's going to go ahead and set up and deploy your Kubernetes cluster in Azure. The second command is that optional command I mentioned. That's going to install the CLI or kubectl down to your system. If you already have it installed, you can skip it. Then the third command, or second, depending on how we're counting here, AZ AKS get credentials. That's going to get the credentials and essentially create the connection from the AKS cluster running in Azure down to your local system. So you specify, again, the resource group and the name that you specified in the first command, and that's it. You've now fully provisioned a fully running AKS cluster in Azure, and you have your computer authenticated to speak to it. The next command you go into is kubectl commands. It's Kubernetes commands. I want to get nodes. I mentioned to you when you run this first one, it's going to deploy out 3 workers for you. I also mentioned how easy it is to scale up and down. So if you want to manage your cluster, you can do AZ AKS list, and you can see what your cluster is running, what version of Kubernetes. You can upgrade easily with just one command, again with the flag of what Kubernetes version. And by the way, I know they announced this morning in the keynote that if you wanted to do this from the GUI, you can actually now do it even from the portal, where now everything you do is just go in and click. And then again, kube-get nodes, you can see the version was upgraded from 1.77 to 1.8.1. And the final command was what I mentioned. When you start off deploying with only 3 nodes, you can easily upgrade to 10 or 50 to 100 with the agent count flag. It's incredibly simple. So why does this matter? Well, this is Azure Kubernetes Service. This is our managed solution. You can run Kubernetes anywhere. But Kubernetes without AKS means that you're also in charge of the master VMs. You're in charge of the control plane, and you're in charge of the agent pool, which means you have to focus about hardware upgrades. You have to focus about canonical upgrades. You have to worry about Kubernetes individual components. It's not that self-healing, rapid growth, easily scale and add more agents to your cluster. It's unmanaged. But with AKS, we take care of all this for you. And because we take care of it, we don't charge you for the master VMs. All you have to worry about is your agent pool. So that empowers you as developers and operations to focus about what you really care about, which is delivering that value, that software value to your end users, right? So now we're going to dive right into what simplifies the Kubernetes experience. We've talked about Kubernetes. We've told you how easy it is to get started on Azure. But there's more tools that simplify your experience, and specifically your experience as developers. We're going to focus on 2 tools today, but this is a host of tools that we have available, and they're all open source, by the way. The first tool is Draft. Draft streamlines the Kubernetes deployment and development. It also works in collaboration with Helm. Helm is the package manager for Kubernetes. You can think of it like pip or a NuGet. If you do use a Mac like I do, you can think of it like Brew, or on Windows, Chocolatey, Box Starter. It's a package manager. But it is so much more, and we're going to deep dive into that today. We also have Brigade and Kashti, which, frankly, we just don't have the time to dive into. But those are also tools you can look into on your own time. So we're going to start with Draft. What is Draft? Draft is simple app development and deployment into any Kubernetes cluster, not just Azure. If you have a Kubernetes cluster, you can use it. How does it work? Using 2 simple commands, developers can begin hacking on container-based applications without requiring Docker or even installing Kubernetes themselves. However, in today's demo, we actually do have Docker running locally. It's Docker Edge using Kubernetes, everything set up. And when Abel and I first took a look at writing the session, because I mentioned I do use a Mac, we didn't know how hard it was to set that up and configure it on Windows systems. So we actually set out to make that simpler. Abel has written 3 blog posts already that walk you through the entire process. I took his blog post and turned it into code. And at the end of today, my scripts are going to be available online, where you'll actually be able to go run a script and set up your entire environment with one command. It also has language support. So Draft can detect which language your app is written in, and then it uses what's called draft packs to generate Docker files for you, so you don't have to know how to write one. It generates Helm charts, and we'll talk about what that means later in today's session, with best practices for whatever language you specify. If you're doing .NET, you're doing Python, you're doing Go, we have draft packs available. So with that, I'm going to bring Abel up on stage, and we're going to go into a demo to show you how powerful Draft and Helm is in conjunction with Kubernetes.
Thanks, Jessica. So how many of you guys out there, or you people out there, have deep knowledge in Kubernetes right now? A couple people, hands went up. How many of you are pretty new to all of this? Most of you guys. All right, then this talk that I'm about to give is to you guys. Because Jessica just dropped some amazing knowledge on Kubernetes and Helm and Draft. But like I said in my intro, I'm a developer. I sling code. That's what I do. So my knowledge on Kubernetes and networking and nodes and load balancers and all that nonsense is pretty tiny. And partly it's because I'm a lazy dev and I really don't want to know that stuff. And partly it's because that's not what I do. I write code. However, in today's world, in order for me to be successful in this container world that we live in now, there's a minimum set of knowledge about containers that I do need to know. So for instance, I do need to know what a container is, right? From a high level, we all know what a virtual machine is. We virtualize the hardware. Containers, we virtualize the OS. So now, as a dev, all I have to worry about is my app code and the data that it runs off of. Perfect, cool, I can deal with that. Docker, what is Docker? From a super high level, that's the technology that's going to run my containers. Hooray for that, I got that as well. Kubernetes, what's Kubernetes? I had no idea, so I pinged Jessica and I was like, man, what is Kubernetes? And of course she says, oh, it's orchestration. And she's looking at me like that explains everything. It meant nothing to me. And I know it means a lot to a lot of people, but for an old school Windows dev like me, it meant very little. So I kept on asking questions. And eventually I realized, oh, Kubernetes, and this is probably not the official definition of what it is, but from my mind, this is a framework that sits on top of Docker, where now you can set things like load balancers with 7 instances of my app running. You can set how it scales up and scales down and how it self-heals. And you can set all that infrastructure type stuff, all the stuff that I've never cared about. Yeah, you can do all that infrastructure stuff in there. All right, good enough. She's the expert. I'm going to let her deal with that, right? And Helm, what's this Helm? What does she say? It's a package management for Kubernetes. Like Chocolatey, like NuGet. And that's when I got extremely confused because I'm like, wait a minute, container isn't the container image of my app? That's my app. And so Jessica had to remind me, your app is way more than just your code. And I'm like, no, but my code is everything, right? But she's right, because my app is, not only is it my code that's running, but it's also the infrastructure that it's running on. That's extremely important. It's both parts of those. So using Helm, you can create things called Helm charts. And I asked Jessica, what are Helm charts? And she started showing me a bunch. Meant nothing to me. But what I realized is these are YAML files that describe the infrastructure that my app is going to run on in Kubernetes. So now we can take these Helm charts and create a Helm package. And what's a Helm package? It's a collection of these Helm charts which describes the infrastructure that I'm going to be running on. And it also has a reference to my image. So now we can use Helm to deploy these Helm packages, which is the infrastructure definition and my application as an image, into a Kubernetes cluster. Wow. Things are starting to make sense for me, right? And anyone that's deep in Kubernetes, they're probably rolling their eyes at me because this is so simplified. But for me, an old school Windows dev, I'm like, this is good enough. So what about Draft? Draft is a tool that makes my life as a dev easier because it's a dev tool, right? In order to do all of this Docker container, Kubernetes madness, you need to have a deep understanding of containers, of Dockers, of Kubernetes, of Helm. The first thing you need to be able to do is create a Docker file, right? Because a Docker file, that's what you use to create your image. Well, Draft makes all of this stuff easy for me. Because with Draft, it will auto-create for me a Docker file. It will auto-create for me a Helm chart. And it simplifies the workflow in my inner dev loop. And what I mean by that is if you look at the DevOps lifecycle for container dev, you get something that looks like that, right? The stuff in red, 1 through 7, that's my inner dev loop. That's what I'm doing all the time. I have to create my project. But not only do I need to create my source code, I now need to go and create a Docker file, whatever that is. I need to create Helm charts. Great. I'm in trouble already, right? But even if I did know that and I created those, now I go in and edit my code to make it do whatever I need it to do, right? This is what I love to do. Edit my code, click save, compile. Now I can debug it locally. But after that, what do I need to do? I need to take my code and turn it into a container image. And I need to deploy it into a Docker registry. And then from there, I need to push that into a Kubernetes cluster so then I can debug it in a Kubernetes cluster. And then I need to do that over and over and over again until I think is good enough. I can check the code in. Then my CI/CD pipeline kicks in. Right? I check it in. My code is built. An image is created for me. It's pushed up to a container registry. A Helm package is created. And if everything looks good, my release pipeline will use Helm to deploy that package into my dev, QA, UAT, all the way out into production. So steps 1 through 7, my inner dev loop, that makes my head hurt. The thought of needing to do that over and over again makes my skin crawl. Steps 8 through 10, that's like perfect DevOps world, right? But draft makes everything easier for us. With draft, my inner dev loop becomes tremendously simplified. So now I can go ahead and create my project, just the source code, and immediately after that, I just type draft create. And that's going to create for me my Docker files, and it's going to create for me my Helm charts. And after that, I just modify my code, and when I'm done, I just type draft up. And that one command is going to build my application. It's going to containerize my application, create a container off of that. It's going to deploy my container that I just created into a container registry. And then it's going to push that image into a Kubernetes cluster for me. And now, if I want to debug my app, I don't have to jump into Kubernetes and mess with ports and routing and all that nonsense. I can just write draft connect, and it'll automatically create a proxy for me, and I can immediately browse into my app and start debugging. That sounds much easier. That's my inner loop, so I do that over and over again until I check it in, and it flows through the CI/CD pipeline. That right there is so much simpler. It is almost DevOps Nirvana, right? So what we're going to do now is we're going to jump in. We're going to jump in, and we're going to go ahead and show you live exactly what that looks like. So let me jump into number 4, I think is where I'm at. And we'll do everything that I just said live. So the first thing that I'm going to do is we're going to go ahead and create a brand new project. So I'm just going to create a .NET New, an MVC project, and I'm going to call this project Build 2018. So if I cd into my Build 2018 directory, do an ls, you can see this is just .NET Core template application for an MVC app. All right. The next thing I'm going to do is I'm going to bring up Visual Studio Code, because that has rapidly become my favorite editor of choice now. And VS Code is smart enough that it's going to look at these files and determine that this is a C# project. So it's going to ask, do you want to load everything for C#, which of course I do. And so now it's going to go ahead and create for me my VS Code folder. So I have my app code. I'm going to bring up my terminal right now. And what I'm going to do is do a draft up. Or maybe I won't. You know what I need to do? I need to do a draft create. I'm so sorry. Let's do a draft create first. So what that will do is that's going to fly through my code, examine it, and say, this is a C# code. Let me create for you everything that you need for draft. So it's going to go ahead and notice it's created for me a Docker file, and it's also created for me my Helm charts. And these are going to be a Docker file and Helm charts that make sense for the technology that I picked, which was C#. So now I can do a draft up. And that's going to build my application, create my container image, push it into a registry, and then stick that into my Kubernetes cluster. Bam, just like that. And if I want to see my app running, I can do a draft connect. It'll create my proxy for me. So I'm on localhost 5157 or 570. Let me copy that, and we'll paste it in here. And hooray for that. There's our application running in a container hosted in a Kubernetes cluster. So that, as my inner dev loop, becomes pretty simple, right? So let's make some changes. This is great. I'm going to jump into my controller, and in my home controller, let's add some code changes. And I'm going to go ahead and in my About page, let's add in datetime.now. So now, if I just do a draft up, it's going to go ahead, build my app, create my container for me, push it into my Kubernetes cluster. So if I do a draft connect now, it'll create my proxy for me. Let me go ahead and find my URL. I'll copy and paste it, put it into my browser, click on my About page, and there are my changes. Once again, inner dev loop becomes much, much easier. Now, what would be incredibly awesome is if I could actually debug this while it's running in a Kubernetes cluster. Because as all of us devs know, debugging is a vital part of our inner dev loop, and you absolutely can do that. However, before you can do that, we do need to make some changes. So the first thing that we need to do is we need to install the debugger into the image that's going to be running our application. Right? So we need to go into the Docker file and make some changes. So the first part of my Docker file is where I'm building my app. And as you can see, I'm building this app, and I'm building it in release mode. If I want to debug, I better build this in debug mode. And then in stage 2, I need to, this is when I'm creating my image that's going to run my app. I'm going to need to add some script in here. And the script that I'm going to add here is going to install the .NET debugger into my image in the /vsdbg directory. Right? So we'll go ahead and save that. Now, the next thing that I'm going to need to do is I'm going to need to change the way that I launch my debugger. So let's go into my launch file. It's in VS Code, launch.json. And instead of launching the debugger locally, what I'm going to need to do is I'm going to need to launch a remote debug session, and I'm going to need to connect that to the debugger that's running in the container. Right? So what I'm going to do is I'm going to call docker exec, and I need to pass in the container image ID. So we made those changes. Let's make sure I save everything. Let's do a draft up. It's going to build my image. It's going to push that image into my Kubernetes cluster. Remember, I do need that container image ID. So let's go ahead and do a docker ps. And let me grab the ID and copy that. We'll go ahead and paste that in here, save that. Let's jump into the home controller. Let's add a breakpoint. Now I'll go ahead and press F5 to debug, and it's going to ask me, which process in your image do you want to connect to? So of course, I want to connect to the one that's running my build 2018 to DLL. So now it's connected. Jump into my terminal. Let's go ahead and do a draft connect so I can find my proxy. Copy and paste that again. Here's my app. Go to the About page. And bam. Check that out. It's hit my debugger. So now I'm able to step in, step out. I can look at values. I can do everything that we as developers want to do in terms of debugging. So what is it that I just did? I am now debugging an instance of my application that's running in a container hosted in a Kubernetes cluster. I'm debugging that. That's freaking insane. That right there is awesome because that completes the inner loop for me. I don't have a problem iterating like this over and over and over again. This makes my world as a developer really, really nice. Now, you notice I didn't touch any of the stuff that's in the Helm charts, right? For good reason, because I don't know a thing about Helm. Well, I know a little bit, but barely anything. But I have someone on my team i.e. Jessica, who is an expert in Kubernetes and also Helm. So as a team, all I need to do is just check this into source control. Everything will be checked in. Jessica can jump into the Helm charts, tweak them, and make everything correct while it gets sent down the CI/CD pipeline and deployed all the way out, potentially, to production. Right? So let me go ahead and check all this code in. So I'll go ahead and check my code in. And I'll push everything back up to VSTS. So once everything is in VSTS, let's jump into VSTS. I'll refresh this. And voila, my code is now in source control. So this is going to kick off our CI/CD pipeline that Jess and I set up earlier. And it's going to deploy, but it might be a little wonky, right? Because I didn't set up any of the Kubernetes infrastructure. I'm just using whatever is default from the Helm charts. But Jessica's going to get a notification. She's going to know that. She's going to jump in, and she's going to make everything better now. So Jess, make everything better.
Thank you very much, Abel. All right, so let me switch over to my computer, which is a Mac, because I don't know how to do his stuff, just like he doesn't know how to do mine. So the first thing I'm going to do is I'm going to first go over here. Let's go ahead and refresh. I also want to make sure I'm going to kill this command that I'm running down at the bottom. I'm going to rerun it. For those who are new, I just have an alias set up for K, but it's kubectl proxy, creating a proxy to my Kubernetes cluster in Azure. And if I go refresh this page, I've set up previously, prior to our session, I've set up a dedicated namespace for our application to be deployed to. It looks like our build is probably still running. Let's go ahead and refresh real quick. As soon as this build does kick off and release, let's go take a look at our releases. All right, let's go ahead and refresh. We want to see some orange. Look at that. All right, so we have an error. He pushed the code, it went through the pipeline, but it's actually not working. Why? Because there's certain things in the Helm chart that me as operations knows about that he doesn't know about. But what's important is he doesn't have to. So we know that our application doesn't work. We can see that our application doesn't work right here. build18.k8s.az.jessicadean.com. I know it's a mouthful. But let's go ahead and open up. First off, again, going back to terminal, I'm going to do an ls on my top pane here. I don't have anything in my Git repo because I haven't done a Git pull. So I'll go ahead and do a Git pull, hit enter. I'm going to pull down all the changes that he just pushed. Now, just because code is also my favorite editor, I'm going to go ahead and open code, which may have been previously open. Go ahead and make this a little bit bigger. And I don't know about any of his app settings, CS project. I do not know C# at all. I have sent him frantic text of, how do I do this? What's a return or view? I don't know that stuff. But I do know charts. And to make our application work, the first thing I'm going to have to do, and we'll make this just a little bit bigger here, the first thing I'm going to have to do is give authorization. If we go back and look at what the actual error is, and just zoom in here real quick so the people in the back could see, we're getting an authentication is required. That's because when it went through the pipeline, it pushed my Azure Container Registry, but our deployment actually doesn't know how to talk to the container registry, right? It's private. So we have to set that up. So the first thing I'm going to do is I'm going to actually add in a value in my values file. We're going to talk about how this stuff works a little bit later. And if you're going to want to know the snippets I used in today's demos, it's actually going to be on a blog post that's going live at 2 p.m. I'm not going to deep dive into it. We don't have time. But I just added in a value for image pull secrets so that when it does end up doing the deployment, it's going to know how to communicate with my Azure Container Registry. But the values is just the knobs and dials in Helm, right? It doesn't actually tell it much more than that. I have to give it values. So I have these templates that were created when he ran draft up or draft create. So I'm going to go to the deployment YAML. You'll notice a bunch of these are just parameters, dot values. I'm just referencing other points in my values file. So I'm going to scroll down here to right above the container spec, and I'm going to add another section in here. We're going to go ahead and add, if the values is filled out for image pull secrets, then create a part of our deployment file that gives it the image pull secret name. Great. So that's awesome. Now I've gone ahead and fixed that error. But I actually want to do something a little bit more because I am IT, I am operations. If I have 50 or 100 apps running on this Kubernetes cluster, I'm not going to want 50 or 100 services or load balance services running. You'll notice right underneath image pull secrets is service. And underneath the name and type, the type is said cluster IP. There's 3 different types of services you can create in Kubernetes. You can do cluster IP, you can do node port, and you can do load balancer. Cluster IP and node port are internal services. They're not externally accessible. To have it be externally accessible, you need a load balancer. You need something that's externally accessible. But what I've configured the Kubernetes cluster to use is actually an Nginx ingress controller. And again, that's going to be part of the blog post that's going live at 2 p.m., so you can deep dive into it. So I'm going to go ahead and enable the ingress. And then just like what I did in the deployment YAML for the secrets, I also have to do the same thing in my ingress controller. So I'm going to save that. Now I've updated everything, so now I've set up our networking, I've set up the image pull secrets. I'm going to go ahead and make a commit. We'll go ahead and add all this, do demo, and now I'm going to push. And we'll deep dive, we'll talk about how Helm charts work and the structure after this demo. I just kind of want to show you the power. So just like what Abel did, if I go back to builds, I should see a build in progress. And I do. So it's going to go through the process. I can show you very briefly what it's kind of doing. The first thing it's doing is it's building an image. It's pushing the image. Again, it's using that Docker file that was created from draft. It's also using Helm. It's setting up the agent or the computer that the build is running on. VSTS gives you agents to use. You can choose Windows, Linux, or Mac. I'm using a private agent because when you're building Docker images, you're pulling layers and caching layers. The builds will run faster when you use a private agent. I'm setting Helm up on the build computer, and then I'm actually telling Helm to package up those files, package up that Helm chart, and hand it off to release. Let release take care of it. So now if we go over to release, we should see that there's a release in progress, which we do. And this is just going through the pipeline, right? This is just DevOps practices. If I edit and take a look at what's actually happening in this release, just like what you saw in build, there's going to be, aside from the artifacts, that's what we handed off, that's that tarball file. But if we go into our environment, there's 3 tasks. Just like what I did in build, I'm installing Helm on the system, I'm initializing it, Helm is a client, we'll talk about that, and then I'm running a Helm upgrade command. And that's what's taking care of my deployment. I'm connecting my Kubernetes cluster, which you can see on the right-hand side. I'm specifying the resource group, the namespace, the command I want to run, the file path. I'm just filling in blanks. And right here, underneath arguments, I've set the image repository, and I've set the image pull secrets. So that's setting everything full circle. That's why it didn't work when Abel did it, but then I added the values in to make it work when I did it. Now, I will say this is bleeding edge technology. Sometimes it can take a little bit to refresh. So we'll make sure that it looks like it's green over here. So it looks like everything is now green. We have the deployment. We have the pod, any replica sets. We can see the ingress that I just mentioned earlier, the build 18 that was set up. And I even see the services that are running. So now if I go back to the page and refresh, we should see his application fully working. So that's the full pipeline. With me not knowing any C# and Abel knowing his code but not knowing Helm, we can work together. We can collaborate. We can still utilize these services and have something rapid. This is cool, but let's go a little deeper. Let's talk about what actually happened, because I know there's developers in the room. I know everyone might be a little confused. So first off, as I mentioned, Helm is a package manager. Helm is the best way to find, share, and use software built for Kubernetes. Because we packaged up that Helm chart, that tarball, we can actually easily distribute it. I can even put it in a private Helm repository the same way I would an image. I can manage even the most complex workloads. So you saw there were 3 files I edited. One of them was deployment, one of them was ingress. In Kubernetes, you use YAML files to handle your deployment or your pod creation. That's your container. You have a service YAML often. That's your external service, right? That was that load balancer, cluster IP, or node port. That's what's connecting to the pod. You have an ingress controller if you're doing deep networking on the ops side. You can have persistent volumes claims, which is where you want data to persist from one pod to another. Same thing down to database instances. You can have really complex workloads, and you can manage the most complex ones because you package it up in a nice little box. You also can have easy updates. You take the pain out of updates because you can do in-place upgrades. You saw in the deployment when I briefly showed you VSTS, I used a Helm upgrade command. But what you didn't see is I checked a box in VSTS that said install if not present. So it's going to install initially, and then it's going to easily upgrade every release after. You can also simply share charts, because I did show you that they're tarballs. And then you can even use a Helm rollback command, which we'll show in a really quick demo here shortly how that works. So this is how Helm charts work. It allows you to define, install, and upgrade even the most complex Kubernetes applications. You put all those different files that I mentioned earlier, you put them in a nice little box that then just runs on top of your little Kubernetes cluster. That's great, but that still doesn't tell me what Helm is. Death to copy and paste. No more indent errors. If you have ever written YAML, tabs or spaces. Yeah. Everyone has run into this issue. It's a pain point we've all had to overcome. So Helm was set out and was designed to solve that. We mentioned that Helm is similar to NuGet, pip, chocolatey, or brew. It combines multiple Kubernetes resources into one versioned unit. That's called a chart. And templates provide default behavior and the ability to override. You can even do things like upgrade, and you can do easy deployment of pre-built apps. There's actually a suite of pre-built applications already available. If anybody in the room has ever had to set up a Jenkins server and knows how ridiculously complex and annoying that can be, you can set up a Jenkins server using a Helm chart in less than 5 minutes. It's incredibly powerful. And on top of that, you can override anything that you would need in your Jenkins server or your Artifactory server or your WordPress server. You override it with either the set command that I showed you I was doing in my CI/CD, or you can override it with the values file, which is the knobs and dials. Helm was started by a company called Deis. It was originally a hackathon project, and Microsoft acquired Deis last year. It's actually been just over a year. Helm was first announced at the very first KubeCon in San Francisco in 2015. Kubernetes has only been around for about 3 years. So has Helm. Here's the architecture. Here's how it's working. You kept seeing in the demo that I kept saying Helm init, Helm client. Helm is the local client. That's the command line tool you're running from your system. Tiller is a component that Helm works with. It uses gRPC to interact with the server. So Tiller gets deployed on your cluster. Helm is used locally. Using gRPC, Helm can interact with Tiller that's talking to the Kubernetes API that's talking to the application. It's really cool. So again, Tiller is an in-cluster server that's interacting with the API. And the chart is that collection of resources. So what does that look like visually? Visually, you have your the pink or the box off to the left for anybody who can't see that. It's Helm init, Helm upgrade, Helm delete. All your commands you're running locally gets handed off to Tiller that's running in your Kubernetes cluster, wherever your Kubernetes cluster is. This is not specific to AKS. When Abel was demoing this, this was working locally on his system. It didn't hit my Kubernetes cluster until we did a git push. Then Tiller takes it, passes it off to the Kube API server, which then passes it off with the chart and values to what's called a release. So I'm going to show you really quickly here how that Helm upgrade and all that stuff kind of works. And to do that, I'm going to use a CI/CD tool known as CodeFresh. So you can set up this pipeline. You can use these tools with anything. It doesn't have to be VSTS. You can do it with Jenkins. You can do it with Travis CI, Circle CI. I like CodeFresh because they actually have really rich integration to that same Kubernetes dashboard I showed you earlier. I get it right in my CI/CD tool. And so for demo purposes, it makes it easy for me to show you what's going on. First off, if I refresh, I can see that I actually already have 2 namespaces set up. We have that build namespace, which was the deployment that we just deployed. And then I have a build 18 CodeFresh. What is that build 18 CodeFresh? That is this Croc Hunter application. For anybody who's ever followed me online, I talk about Croc Hunter all the time. It was written by Lockie Evanson, who worked for Deis, now works for us. He is one of the main maintainers of Helm. Right underneath this particular play thing, where if I click it, I'm shooting fish at crocodiles. If I zoom in, you can see the commit ID. So I love this demo because it makes it easy to show you the value of Helm. So here's my Croc Hunter. I deployed it with Helm. I already have a pipeline that's going through. It's running in this namespace. If I go to my Helm releases, I'm going to go to the build Croc Hunter. You can see that I actually have 7 revisions, But I only have, if I go under history, I only actually have upgraded technically 3 times. I have version 2 and version 3. This morning when I was testing at 9 a.m., when we go back over here, I rolled back to version 3. So if I want to roll back to version 2, which has a different thing that I can shoot, rather than making the crocodiles die with fish, now I can shoot them with lasers. Let's go ahead and roll back to version 2. So I find my version 2, and I'm just going to go ahead and hit the rollback command. Now all this is a GUI of the Helm rollback command that I just mentioned earlier. This is how powerful it is. So this is going to go take the Helm charts, take my code, take my Docker file, whatever image that was referenced, whatever that was tagged as in my image repository, because it's kept in my infrastructure as code or my little Helm chart and it's all a little box, it's going to roll it out, it's going to swap in everything, and it's going to do what's called a rolling upgrade. So there's going to be no downtime. And I'm going to be able to immediately see that change live. So as long as the pods are done upgrading and cycling through, I can now zoom in here, scroll down. I see that my commit ID, first off, has number 1 changed, which is a good thing. Now if I hit start, I'm now shooting lasers. In less than 10 seconds, I can revert my code back and my image back and my chart back. And everything's also in version control, right? It embodies DevOps, and it simplifies my development experience, my operations experience. If we go back to the pain points earlier that we talked about, it just took all of that and blew it out of the water. So now let's go and dive even deeper into Helm and what we're talking about today. So you've seen the power of Helm, you've seen the power of Draft, but it still doesn't really explain how it's working. So first off, charts. Charts have structure. As we saw when we went through and I kind of, on the left-hand side, was moving around in VS Code and messing with my deployment file or my templates or my values, all of that has structure. There's a set of conventions, including file and directory names. And as we've talked about, charts can be packaged up. The structure is very simple. If you take a WordPress chart, which is publicly available, you can go to hubs.kubeapps.com. Those are publicly maintained, stable release charts, readily available for you to use. You'll have a chart YAML. You'll have a README file. The values, which is the default configuration. That's the knobs and dials. That's why I kept making changes to the values. The charts directory is just a directory containing any number of charts that deployment is dependent on. So when I clicked on charts that was created from Draft in Abel's application, underneath that is C#. That's his folder where all the charts for that application lived. Same thing for if you go to charts and underneath Croc Hunter, it would be charts. The subdirectory of that is croc-hunter. By the way, if you all want to become your own crocodile hunters, that repo is publicly available on my GitHub, complete with the entire pipeline I used in either Jenkins or CodeFresh, and you can go get started playing around with that today. But that's where all those files live. They're templates, they're charts. This is how this stuff works. More so, the chart YAML itself has a name, has a version, a description, maintainers. This gives the information so that once I've packaged it up and I distribute it, the next person who uses it can get information about how to use it, who to contact if there's something broken. It, again, enables that rich collaboration. You also have the Helm values file. A values file in any Helm chart you use is going to be the most powerful file you have. Perhaps not more so than the template, because the value won't work without the template, but the templates won't work without the values. It is the knobs and dials. It contains the default values for your deployment. That's where you can set CPU usage or memory or image pull secrets or your service type. All those things that you would normally have to have in 5 or 10 or 15 different YAML files, you now have in one location, and then the charts are just parameterized version that go back and reference that chart, that values file. You can use -f to provide your own values. So if I were to do a Helm install stable from the stable branch for Jenkins, I would use a -f to say values. And here's my own values that I want for my Jenkins deployment. And I have an example of that on my GitHub. I can also use the set flag, which is what I use in my pipeline, to override anything that I already had hard-coded in the values. So nothing's ever final. I still have it in CI/CD, in my release management, or in my infrastructure as code and my version control. Templates. Templates are built on Go's templating language. And it has in addition, 50 or so template add-ons. Almost anything goes. Remember, this is still new, it's still experimental. Draft and Helm are being updated constantly. I will say that there have been bugs in upstream releases, but the team is incredibly responsive. These are all open source tools. If you find a bug, or if you want to collaborate, if you want to add to it, if you want to improve the experience for Windows, by all means, submit a pull request. But it's also useful in generating random values. You'll notice in the GitHub that I have, on my, which is going to be in a slide at the end, but when you go and first deploy out your Jenkins server, it's actually going to generate a random password for you. You don't even have to define that. It's going to set it up. It also has predefined values. So you kind of noticed, if you were quick at kind of looking what I was editing, that you have things like release name or release namespace. All of these are predefined values that are referenced among the templates. And again, we did talk about chart. You have the values from your charts. You can reference the chart version and the chart maintainers as part of your predefined values. Chart versions use version numbers as release markers. So you saw that when I was using CodeFresh to roll forward and roll back. It had the revision numbers and the release markers. And then furthermore, obviously it includes a README, a notes, templates. The notes is actually really cool because at the end of every release or deployment, you can actually put anything you want in notes, and that's what's printed after you run a Helm command. So it'll be printed on anyone's computer. So you can package that up, and let's say you wanted to include notes of where somebody could go view their application or what their password might be. You can parameterize that, and then when you package it up and distribute it, anyone who uses it is going to be able to have those notes or that values file propagate that information. And then dependencies. A chart can depend on any number of other charts. You can essentially link these things together to where one chart relies on another chart relies on another. All you have to do is copy the dependency charts into the chart subdirectory. And the requirements YAML would allow you to declare any required dependencies. Other hats, as we've talked about, it offers lifecycle management, update, and rollback. You even have config management, testing, repeatability. Remember all those practices and topics that we talked about in the beginning that apply to DevOps. Helm and Kubernetes embody that, embrace it, and more so fuel it. It makes both the developers and operations lives simpler in the workflow. So all of this probably sounds really awesome, but is probably really overwhelming. This is a 300 level class. So I know that talking about this stuff, your heads might be spinning. I kind of breezed through my kind of demo because I know I have a blog post that just went live 2 minutes ago. I also didn't deep dive into the VSTS workflow as far as how I set up those tasks. But guess what? I actually mimicked those tasks after a new project that was, again, mentioned in the keynote this morning, but the Azure Kubernetes, or AKS, DevOps project on Azure. So we're actually going to I'm going to bring Abel up, and he's going to demo how you can get started. So the second you were to use AKS DevOps project, it's going to actually create that entire pipeline that I used in my demo. It's going to set it up for you. So you don't have to know any of this. You can learn it in your own time, and you can actually learn from the best practices because Azure will do it for you.
So how many of you people set up CI/CD pipelines? Wow, that's way more than I thought. How many of you people think it's a lot of fun to set up a CI/CD pipeline? Less number of hands. Yeah, I'm kind of in that boat as well. And today, with the new Azure DevOps project, we make it ridiculously simple to set up a full end-to-end CI/CD pipeline for Azure Kubernetes service, and you get all of this with just a couple of clicks. So let me show you what I mean. We're going to jump into my Azure portal, and we're going to go ahead and create an Azure DevOps project. And the first thing it's going to do is going to ask me, what language do you want to use? Now, it's going to show a whole bunch of different languages that we can choose from: .NET, Ruby, Go, et cetera, right? Surprise, surprise, I'm going to choose .NET because I am a Windows dev. I'm going to click Next. I'm going to choose .NET Core, click Next. Now it's going to ask me, what infrastructure in Azure do I want to deploy to? We can deploy into web app, AKS, virtual machines, et cetera, right? For this demo, we're going to choose Kubernetes service. We're going to click Next. Now it's going to ask me, what instance of Visual Studio Team services do you want to use? We can create a brand new one directly from here, or we can use an existing one. And I'm going to choose my demo account. And then we have to give this project a name. So I'll call this Able AKS Demo. Click on Done. And it's going to validate. And in a couple seconds, bam, that is literally all I need to do. I can now kick back, relax, and let just Azure do everything for me. So what is Azure going to do? It's going to go ahead and create for me a team project. It's going to create for me sample code in the language that I picked. In this case, it was .NET Core. And it's going to put it into my repo. It's going to create for me a CI/CD pipeline that makes sense for the technology that I picked. So it's going to build my application, create my image for me, push it into a container registry, and when it flows through the pipeline, it's going to deploy it into infrastructure that it created for me, AKS. So when you're all done, you get a portal that looks like this, where on the left-hand side, you see your CI/CD pipeline. And on the right-hand side, you see all the infrastructure that it created for you up in Azure. Now, all of these links, these are deep links that take you directly to those resources. So if I click on the code, this will take me directly into VSTS, into the repository that holds my code. And like I said, this is just an ASP.NET sample code. That's all it is. If I go to my build, we can see the build that we've created for you. In this build, let's go ahead and edit this. This build, we created a build for you that makes sense for the technology that you picked. So what that means is we're going to create our build by first building the image. Then we're going to take that image, we're going to push it into a Docker registry. When that's done, we're going to install Helm, and then we're going to use Helm to create a Helm package. This should look exactly like what we were showing you before, right? Because we use best practices. Now, once it's done building, we'll send it through our release pipeline. And here's our release pipeline. And once again, we create a release pipeline that makes sense for the technology that you picked. So in this case, we're just deploying into one environment, which is going to be a dev environment. And it has 3 tasks. These are Helm tasks. So we're going to use Helm to install that Helm package into the AKS instance that we created. So there's nothing more for you to do. Everything just works, right? You don't have to configure it. You don't have to tweak it. You can just start modifying whatever you want to now. So even though everything just works, you still have full control over everything that you need to do. So for instance, maybe I don't want that sample code. I want my code. Here's my code repo. This is just a Git repo, right? The white screen. This is just a Git repo, which means I can just clone this repo onto my hard drive, swap out the sample code with my code, check it in, and bam, it will send it through the CI/CD pipeline. Maybe there's some extra stuff that we want to add in our build and for our Helm charts or in our release pipeline. It's fully extensible. It's fully customizable, where you can go in and make it do whatever you need to. And when you're all done, you'll go ahead, and that was completely the wrong button. You'll go ahead and deploy your app all the way out into AKS, right? Just a couple of clicks, and you have this full CI/CD built out for you, ready to use. We are the only cloud vendor that makes it so insanely easy to go from nothing at all to a full CI/CD pipeline in a variety of technologies, including Kubernetes. All right, thanks.
Thank you, Abel. That was really cool. So I know he talked about CI/CD pipeline, all of that was created. What I want to make sure is explicitly stated, that didn't only create the VSTS instance and release project and all that. You can, number one, if you don't have a VSTS account, it'll create it for you. It created the Kubernetes cluster. It even created an Azure Container Registry. You literally can start with absolutely nothing, do that project, and get every single thing we demoed today. And if you want to get Helm, which I just realized I'm not on my computer, so let me go ahead and switch. If you want to get Helm, you can go to helm.sh. And I know everyone in this room is incredibly smart, but I bet you can't guess where draft is. OK, you guys were right. Draft.sh. So if you want to learn about both tools, deep dive, get started, again, it is free, it's open source, go play with it. Both projects have an MIT license, most pervasive license around. Again, it is still in development, beta stage, I would sometimes argue alpha stage, but it's pretty awesome with even where it's currently at in its infancy, just how much you can do with it. And notice also with Helm, the best practices, even the AKS DevOps project uses Helm to release the releases and the deployments. If you also want to learn more about Helm charts and you want to learn how to write your own for whatever reason and you don't want to do draft, you can learn from the best. When I mentioned earlier hub.kubeapps.com, it's just an updated version of kubeapps. When you go to kubeapps, it could also point you to hub. Or you can go to, on GitHub, the charts repo under Kubernetes, and that'll show you all the stable Helm charts. They're pretty sure that those work. That's where I kept mentioning stable Jenkins or stable WordPress, stable Artifactory. It's pretty powerful. Finally, if you want to connect with me or if you want to be your own very own croc hunter, you can go to GitHub, JL Dean. You can follow me also on Twitter, Instagram, GitHub, JL Dean, no relation to James Dean, so there's 2 E's. And you can fork or clone Croc Hunter and become your very own Croc Hunter. It'll walk you through that stable Jenkins instance where you can set up a Jenkins server complete with just a values override file. You have everything up and running in 5 minutes. On top of that, I did keep mentioning that 11 minutes ago I had a blog post go live that actually spoke about how I did some of the networking and Nginx stuff that you saw in today's demo. All that was 2 Helm charts. I'm using kubelego and an Nginx ingress controller. I set those up on my Kubernetes cluster prior. I used my domain registrar, which is actually Google DNS. I routed that over to a wildcard certificate and name server over in Azure using Azure DNS, and then entered in an A record that had that ingress controller attached to it. Now, any traffic that hits it automatically gets issued an SSL certificate from Let's Encrypt. 3 Helm charts, 5 minutes. That's how simple it is, and that's how powerful it is. You can also send me an email anytime. If you want to email Abel, you can do the same thing, but abel.wang@microsoft.com. You can follow him at Abel Squidhead, or tag me and I can connect you. I will say that both Abel and myself are probably more responsive on Twitter than we are in email. Or you can also check out the LOECDA website, which is loecda.com. That also has a list of all our talk schedule and everywhere any member of the league is going to be. Finally, please complete an evaluation form at the end of every session you attend. Your input is immensely important and valuable to us. Thank you very much. We do have about 3 minutes left, so I encourage you, if you do have questions, actually talk to Abel and I offline. That way we can go ahead and free up the room for the next session that's coming in. Thank you very much.